this is the not meant to be the horror story, but I sort of landed with it. Biosecurity threats and risks. I just want to give you a sense of what's involved. I think between Davina and Jan Hendrik, they've sort of set the stage. There are more specifics, there'll be some repetition. And the title, The Ins and the Outs, one has to have respect for one's trading partners. Spain does not want false codling moth. We don't want some of their tortricids. So it's a lot of what I'm going to say is sort of focused on the barrier, not letting stuff in, and the stuff that we don't want, but some of it is relevant to preventing stuff getting out. There we go. Okay, as I said, by way of introduction, it works both ways. What makes certain pests and diseases invasive? Davina has referred to it, pathways. If you have got large volumes of fresh agricultural produce being exchanged, you're going to have a problem. If it's coming out of a country that is heavily infested, it's going to get bad. And the focus is on the nature of that pathway. The other thing, and I've split this talk between diseases and insects. I'm an entomologist, so forgive the bias. Multiple hosts, polyphagous insects, tend to be able to establish in a new country easier than a specific, something with a specific diet. And you're most probably sitting thinking, what about woolly aphid and codling moth? I need apples and pears. Yeah, they came in directly on the crop, historically. Looking forward, the chances are they're going to be a polyphagous type thing. The other one is they reproduce, they have high reproductive rates. That makes sense. Okay, short lifespans coupled with high reproductive rates makes them even worse. And a lot of them tend to be tolerant. They refer to genetic plasticity. It can handle hot and cold, or dry and wet. They are adaptable species, and I'll show you some quite interesting examples. Prediction and prevention. The question, and that's been referred to, is which species out there are a threat? What are they likely to get in? And it's all a numbers game. And where are they going to actually land? And again, it's been referred to, pest risk assessments are critical. And a comprehensive pest risk assessment, and if you're interested, please look it up. There's some very interesting ones. Funny enough, Australia is very, very good at it. In terms of, we're importing stone fruit from Spain, and this is hypothetical. There's a tortricid moth that attacks plums in southern Spain. Is it a threat to us? And you go and you dig out all the biology, how it's controlled, what is its temperature tolerance, where does it do well? And it's quite a long assessment, but it's a cornerstone of this risk mitigation. The other one is surveillance and monitoring at points of entry. That's an obvious one. And we've missed some important ones. We have spotted wing Drosophila. It's just been referred to. It was on the list of potential. It's now the reality. We've known about it for a while, but our first record was from the lungcloof. Without being, I'm not being rude about the lungcloof, but it didn't come into the lungcloof. It came from somewhere. Where did it enter? We don't know. So that surveillance and monitoring is critical, and there are some established surveillance programs in this country on the east, for example, with invasive fruit flies. I'll refer to that later. Integrated systems approach. We've invested in this. Hortgrow has invested in it in terms of a systems approach is a sequential management from field through to harvest, through packing, through shipping, etc. It allows one to, number one, monitor, and number two, hopefully apply various control measures at different points. Disinfestation technologies are also very important. At the moment, we use them on stuff going out. I don't think it takes a stretch of imagination where we will be potentially fumigating stuff coming in, if needs be. Again, Hortgrow's invested heavily in those technologies. And then the last one is, if you're interested, look it up, digital twin technologies, data collection and artificial intelligence. We have a bunch of sophisticated software tools available to us that allow us to model risk. And if you communicate with the exporter and link in scientifically with them in terms of gaining decent data, you can start modeling very accurately. And I think that is very, very important. Just a pleasant photograph of mealybug, seeing that they were talking about it earlier. I'm just going to go through. There are five diseases and four insects, and the fifth insect is spotted wing. It came out. It's now public knowledge. This isn't meant to horrify you. It's better to give you an idea of what do these things do, what sort of threat do they pose, where do they come from, sort of some of the dynamics. So I've done five diseases, 5 insects. Yeah, I'm a Democrat. I did distribute a list. Then the democracy sort of went away. I picked the nice ones, not the difficult to do ones. Okay, this is stuff that we do not have and we certainly don't want. Apple canker, it affects all stages of production. New apple cultivars tend to be highly susceptible, causes shoot dieback, and can also cause fruit rot. The origin, most probably Europe. It's in Australia, New Zealand. That says a lot because their phytosanitary setups are very, very good. North and South America, infested plant material. It's nasty. You don't want it. Risk, very high. And it can be transmitted on fruit. That would complicate our lives. The other well-known one is fire blight. It's a bacterial disease. It's multi-host, or has multi-hosts, including plum, pear, and apples. It spreads. I've seen it. Those of you who've been to North America, the United States, are familiar with it. It's difficult to control. It originated in North America and it spread. Europe, New Zealand, Australia. Australia eradicated it. That's pretty unique. And then it's also in Asia and South America. Again, infested plant material is the pathway. High and warmer climates, it's a bacteria. The warmer your climate, the moister, the bigger the problem. As I say, control is not easy. Brown rot, a monolinear species, an acromycete causing rot. The picture's absolutely horrendous. It's across all our fruit kinds, not what you want. Origin, most probably Europe. It's in Australia, North Africa, and Asia. North Africa worries me, but there is a Sahara between us. Pathways, infected plant material again, high risk. And there should be one more, Alternaria mali, the Asian variety. Thank you, Cheryl, for pointing that out to us. On apple, lesions on leaves and can also affect fruit. It's just one of those very, very problematic, virulent virulent diseases, most probably originated in Europe. Again, infected plant material and fruit. So, a serious risk. The last one, and it was referenced early in the day, plum pox, nasty. A destructive disease of stone fruit, mainly prunus species, and there are a lot of prunus species around as ornamentals, so once it's in, it would be multi-host. And like most viruses, symptoms difficult to diagnose. It's in Eastern Europe and Europe, North and South America. Again, infested plant material, and it emphasizes this plant quality testing, really severe testing of stuff coming into, for example, our breeding, into our breeding program. Risk, moderate, unlikely to enter, but if it does, it would have a huge impact. Another one, this is to me the sort of king of the castle in terms of what you don't want. Xylella, leaf scald, referred to as Xylella. If it's in grapevines, Pierce's disease. I have a problem in the States with it, and it's vectored by an insect. It's a bacterial disease with a very, very wide host range. And as an entomologist looking at it, I think the classification's confused because they're various strains of it. It affects crops that include peach, plum, almonds, grapevines, coffee, and olives. Fairly recently, and there's speculation how it got there, but it was most probably a host shift. It got into the olive industry in Italy. And it's devastating. So it's slowly progressing up Italy. It's got into Sardinia, and it's now in southern France. I'm not sure if it is in Spain yet, but it kills your olive tree. That is catastrophic in southern Italy. Its distribution, Europe, North and South America. Possible origin, America. And one of the hypotheses is that somebody had a bromeliad as an ornamental plant from South America, and it was in southern Italy, and after many years, the shift happened. Okay, infected plant material is a pathway. Risk high, EPPO A1 quarantine pest, that has some weight to it. Prefers warm, multi-host agricultural environments. That's us, or some of us. And it's vectored by insects, xylem-feeding insects. Quite frankly, I think we should invest in just looking at what xylem feeders are active in orchards in case. It's not nice. Okay, I'm now more comfortable. I'm back on my own patch. It was quite fun selecting these. They are interesting insects, but obviously, yeah, let me reiterate, I don't support them, I don't want them, but they're interesting to go and see somewhere else. So this is Epiphyus postvertana, light brown apple moth. A New Zealand colleague of mine refers to it as light brown eat everything moth. It's got the most amazingly wide range of hosts. So in New Zealand, it'll be eating a pine tree windbreak and the apples. So it's a sort of leaf roller type thing. You can see it down there. It's a little tortricid moth. It's related to codling moth. It also eats Octothea, Hoosblom, for example. Australians are rude. They refer to it as Cape weed. Plantago, apples, hada, everything. So it came out of Eastern Australia. It's in the United States. They spent a lot of money getting rid of it, and I think they've almost done that. Got into California. It's in New Zealand, much to the New Zealanders' disgust. Hawaii, parts of Europe, and the United Kingdom. United Kingdom, direct import of this Victorian fixation with taking stuff with you. Okay, risk very low for us. This is one of the ones it's gaining currency. It's spread very, very quickly where it has been introduced. Marmorated stink bug. It looks like a lot of our stink bugs. There's a problem with taxonomists who can identify this thing. There's a problem with people who work on sucking insects. There are very few of them. But it's spread across the states. If you want to, you can ask Vaughan Walton after the presentations about it. It originated in China, Korea, Japan. It's now in the States and it's going across Europe. Do we expect it? Yes, we do. It's a hitchhiker. And Manette came back from a trip to Australia with a horror story where they'd opened, I think it was the New Zealanders, opened a box of new shoes. And there were 27 of these things in the box of shoes. So it gets into motor cars, packing material. It's not nice. Maybe that'll explain why it went so quickly across Europe. The next one is Bactria zonata. This is where it gets interesting. It's already in Africa. If I'm not mistaken, it's in northern Mozambique. It's a large fruit fly. It looks like a wasp. It has a wide host range. It's a very strong fly, active all year, and it'll attack citrus, apples, mango, fig, avo, plum, and the rest, including peaches. Okay, Southeastern Asian origin. It's very similar to Dorsalis. Again, plant material and fruit, local distribution. So it's going to creep down our east coast. Yes, we can mitigate. They are, Jan Hendrik can correct me, but there's already a monitoring grid in place, and I know there are international agencies looking at it. EPPOA1. The next one is Spodoptera frugiperda, fall armyworm, originally from America. It's basically a bollworm that flies far. Traditionally, it's in the warmer areas of Mexico and Central America, and in spring it starts flying north, up America, into the United States, and they are strong flyers. So, yeah, okay, multi-generational flying, and I thought I'd better check that in the literature, and it transpires that one of them was marked in Mexico and had managed to get into Canada within 30 hours. So they had the behavior of getting up into wind and using that. It makes Pennsylvania in a good year in the States, and yeah, it eats everything, including the foliage off your apples or your fruit. Pathway, it's here. How it got into Africa, I don't know, but it's here and it spreads south. So it's sort of a transient invasive. Difficult, and it's a EPPO A1. So I've got a minute to do this. So it's been mentioned, and I must reiterate and support Davina, the confidentiality around invasive insects is tripping up the science. I'm a critic. My colleagues know I'm critical of this. It trips up the science because you don't have access to the information that you need to be able to manage it or mitigate, okay? So PRAs, the systems approach, internal monitoring, everything requires cooperation between all the role players. Polyphagous shottle borer, we're talking to municipalities, we're talking to central government, regional government. We've got to get better at that to control the invasives. We've got to get better at that to control or mitigate or prevent the invasion, right? So PRAs and applied research are critical in this. If you understand the potential invasive, you've got a very good chance of controlling it. Systems approach, I've explained, and if you have an existing IPM program within your industry, you have a much better chance of controlling an invasive. Internal and monitoring and detection are obvious. Ability to react comprehensively, all parties. And then early detection and reaction. Davina said it, Jan Hendrik said it. If you see something odd and you're not sure, it's better to call somebody. Government's good at it. There's plant disease clinic, the entomologists, the technical people, your crop protection specialists can help you. That's it. Thank you very much.